Let's begin this exploration by first going back through and reviewing the construction process of making traditional style frame and panel construction raised panel doors. Now this type of construction and these types of raised panel doors have been around for many, many years. I frankly don't know how far back in history they go, but they've been around for a very long time. In modern times here, we see them in kitchen cabinetry, bathrooms, furniture, of course. Wherever there's a need to fill a large opening, you'll see raised panel, frame and panel type construction. Now, this type of construction, you'll start out first with your design by selecting the style that fits the piece that you're making. So the raised panel or the molding detail on the edges of the raised panel should fit with the style of furniture that you're making. Same thing with the inside edge detail of your stiles and rails. That should fit the style of furniture that you're making. But you'll have to start out, of course, with an overall size. And from there, you kind of work backwards to figure out the size of the panels, stiles, and rails, and so forth. So we'll bring you in a little closer and show you some of those details on this panel before we go on to the construction. Now, for starters, you have to work off of your baseline, which would be the overall dimensions of the door, be it an inset, half overlay, or full overlay door. You're going to need to have those dimensions. Now, this particular panel is 14 3/8 wide by 20 1/2 tall. So that's where my baseline is. From that, I have to figure out all of the rest of the dimensions. Now, sizing the width of your stiles and rails is something of just a feel type thing. Now, you can of course go around your home, measure up what you have for kitchen cabinets, bathroom cabinets, other pieces of furniture for the size of your stiles and rails. What you're going to find is about 2 to 2 1/4 inches is a pretty common size for most door panels, especially of this size. Now, as they get much larger, of course, the stile and rail width can grow with it. If you get a little bit smaller, you can shrink them a little bit, but you don't want to get too small on your stiles and rails. Keep in mind that in this type of construction, where you have frame and panel, the frame is actually all of the strength. That's your structure. The panel, if it's natural wood, is floating inside this frame. So it's not adding any structural stability to the frame. It floats in here because we know as the seasons come and go, fall, winter, spring, and summer, this panel is going to expand and contract. So we have to allow for that. So you'd never ever take a solid panel and attach it to the stiles and rails. We know that we've got our overall width, overall height, and in this case we went with a 2-inch wide stile and rail. It seemed to fit very nicely with the proportions of this door. We could have probably went to 2 1/4. 2 1/2 is probably stretching it too far. It's going to look too bulky, too utilitarian. It's not going to have a nice, elegant look. So that gives us those dimensions. Now we need to look a little bit further as we pull this apart to determine the size of the panel and the overall lengths of the components. Now, during the design stage, it's really important, I feel, to have the actual cutters in hand that you'll be using to both raise the panel as well as to make the cuts along the inside edges of your stiles and rails and the coping cuts at the ends of your rails. Those cutters will give you a variety of different, very important and basic dimensions. For example, this wing cutter is going to establish how deep the groove is in each of our stiles and rails. That will, of course, accommodate our field panel. Now, 3/8 of an inch depth is pretty common for these types of cutters. And the width of the wing cutter is 1/4 of an inch. Now, when we go to assemble this door, of course, we're going to place this edge inside the stiles and rails. And that's, of course, going to conceal part of the edge of our field panel. Now, as we bring that in, we know that we've got a 3/8 inch deep groove. We measured our cutter. But we don't want that field panel to completely go into that 3/8 inch depth. Rather, we want it to go in 1/4 of an inch, allowing an 1/8 inch gap all the way around the field panel. That allows it to come and go with the seasonal changes. So, based on that, we know our overall width of our door and, of course, our overall height. And in this case, we're working with a 2-inch rail on either side. So we would go with our 14 3/8 minus our 2 inches minus our 2 inches, and that would give us our inside edges of where the stile and rails would be, or in this case, the stiles for width. Now then, we would add a 1/4 inch on each side of that field panel to get the field panel's overall size. The same measurements would be done to perform its height calculations. We would go through, take our overall height, subtract 2 for the top and bottom rail, and then add a 1/4 and add a 1/4 to get our field panel size. Now the lengths of the stiles, the vertical elements of the frame and panel construction, those of course are just cut to the overall height of the door. But the rails, we have to account for these tongues that will fit inside these grooves, like so. Now that again is a very simple and basic calculation based on the actual cutters that you're using. Now in this case, we know that our groove is 3/8 of an inch deep, while this tongue, in order to fit in that groove, would also have to be 3/8 of an inch long. So, based on our overall width of 14 3/8, we would subtract 2 inches, subtract 2 inches for each width of the stiles, and then add 3/8 and 3/8 to each end of our rail to get its overall length. So as you can see, going through these different calculations to determine the size of your field panel, the overall length of your rails and so forth, are highly dependent on the actual cutters that you're going to use. So when getting into the design stage, you really want to pick out the profile for not only the field panel, but also for your stiles and rails, get the cutters, and then work off of them to really fine-tune all of your dimensions. So as you can see, it is a little bit of a mix and match as to how you dimension everything. The overall dimensions are pretty much dictated by the cabinet that you're making the door for. All of the rest of the dimensions are highly dependent upon the actual cutters that you're going to use to create all of the edge treatments for not only the field panel, but also the stiles and rails, that inside edge there. So keep that in mind as you're designing your doors and when you get into that final sizing of each of the components, especially if you're working off of someone else's plans. If you're not using the exact same cutters, well, you could end up with a panel that's not going to fit the cabinet that you're making it for. Now we're going to show you a couple different techniques on how to machine this raised panel portion. We're going to show you and give you some pointers on how to work with stock that's not of the appropriate thickness, how to do it in a horizontal orientation with these large cutters, and in a vertical orientation, and we'll walk you through the steps and setups necessary to machine the stiles and the rails. So let's head over to the table saw and the router table to get through the rest of this operation. Now to get started on the stiles and rails, you have to start out with dimensionally correct stock. All the same thickness, the width should be consistent. In this case, I'm using 2-inch wide stock, 3/4 inch thick, and then cut off to the appropriate lengths. Of course, make sure all your stock is flat and all the edges are machined square. Now when we're doing this machining operation, we will be machining it with the front face down against the table surface. So I take the time and go through and mark up the faces for each of the pieces. Now the first cuts that we're going to make are these inside cuts. These go along the inside of the stiles and rails. Now the router bit that I'm using is a white side router bit, part number 6001A. Now as I mentioned before, of course it's going to be in the router table upside down, so our faces are going to be down against the table surface. Now there's two different ways we can approach the setup for this, and it depends on what type of element, decorative element you want along this edge here. Now as you can see, I've got a nice shadow line here created by how this radius comes up and then terminates on this little rabbet. Now if I change the height of this router bit, I could end up with just a round over right here. I don't get that shadow line, so I don't get that interesting effect there, but I can change the way that the router bit, one router bit will give me two different profiles. Now if I go with just this round over like this, my groove is centrally located relative to the thickness of my stock. So that would mean that from the back side of the groove to the front face over here, we would end up with a 1/2 inch of distance. We would have a 1/4 inch here, 1/4 inch groove, and a 1/4 inch on the back side. So I would use a 1/2 inch panel because you do want your raised panels to be flush with this front face of your stiles and rails. Now when we go with this deeper cut, like this, where we get this extra rabbet up here, everything is shifted over 1/8 of an inch. So I'm going to have an 1/8 inch back here, 1/4 inch groove, and then 3/8 of an inch here. So the raised portion of my panel has to be 3/8 of an inch. Now this is the style that we're going to be demonstrating here. It's a very classical look, a very, very popular one, and it works out very well. So when we set up our router bit, we know that from this point at the back side of the groove to the face, we need 5/8 of an inch. Now on the router bit, you can actually make these measurements very easy with a scale. If I measure from the end point of that radius to the back side of my groove, or the wing cutter for the groove, we'll see that it's a 1/2 inch. To get that 1/8 inch rabbet, we would raise the router bit up so that we're at 5/8 of an inch. Now, as far as how deep into the side of the stiles and rails that we cut, you can measure that very easily. It's 3/8 of an inch, so that would mean that your panel would project into that groove a 1/4 of an inch, and then that gives you an 1/8 inch of movement for that panel to shrink and expand. We'll raise the router bit up our 5/8 inch dimension. Lock that in. Now I like to work with a fence, even with bearing guided router bits such as this. To isolate that bearing, I just bring the fence over and back it off a little bit so that I know I'll be riding against the bearing and not against the fence. But this provides good dust collection and some level of additional safety. Now we will be running the stock with the face down, and I'll be feeding with a very good push block. Now if you wanted to take this in several passes, with this type of bit you can't adjust the height. Once the height's set, it has to remain set. But if you didn't want to take this all in one pass, you could adjust your fence in and out and then work progressively deeper along this axis. Now with that operation complete, we've got our groove to accept the field panel. We've got this decorative element along with this nice shadow line here. Now our next step is to make the coping cuts at the ends of the rails, top and bottom. And those will be cut to this exact profile here so that they interlock together. Now we just saw how this router bit cut this profile. Now we're going to use a separate router bit, white side part number 6001B, and then that will cut a matching profile along the ends of each of our rails. Now there are some router bit sets that are reversible, where you would disassemble them and change out components to get the different configurations. The single piece units, where you use 2 different bits, are generally more appropriate for production shops or large volume users. The 2-piece units, because they get twice as much cutting per se, won't last nearly as long. So you can get either style. They both, of course, work for the home shop. So now what we need to do is set up our next router bit to make those coping cuts. Now with our coping bit, we're making a mirror image of the profile we've already cut on the insides of the stiles and rails. So now what we need to do is line up this gap where the bearing is with the gap or the groove where our panel's going to go. Be very careful on this height adjustment. It does have to be perfect. If it's not just perfect, you'll have a step between your stiles and the rails where they join together. Now we can bring our fence over. Again, we do want to ride on that bearing for our guide, so we'll make sure that the bearing is proud. Now the first thing I'm going to do is take a test cut along a piece of scrap stock, and I'm going to do it along its edge. And that'll come in handy a little bit later, but we'll explain that at that time. Well, the test cut has shown me that I'm not at the proper height. As you can see, I've got a step right here. And if I measure that step, it's 25 thousandths of an inch, just between a 64th and a 32nd. So I'll have to adjust my router bit to make up for that, and then we'll go on for another test cut before we start cutting our rails. Now this is what the end of our rail is going to look like. Now as you can see here, I've got some terrible tear out both above and below. So we need to address that while we're making these cuts. But you'll also notice we're going to be cutting across the narrow end of the board. So we're going to need to add some form of stability to help make this cut a little bit more safe, because we don't want to freehand that against the router bit. Now this is the way in which we will be feeding our rails across that router bit. Very dangerous actually without some additional support. So I'm going to be using my little mini sled that I have for my router table. The only thing real critical here, I've got a fence, and that fence is at a right angle to this miter track, so that when I feed the rail across, I'm going to end up with a square cut on the end, not an angled or beveled cut. Now the first two cuts that we'll make on the rails will be at the ends where the router bit will exit against the flat edge. And we'll be cutting with the face down, so I'll get that in there. This is my backer board. And I'm going to be using one of my grippers to help support and hold the workpiece as I make this cutting operation. And that'll make it very safe, and it keeps my fingers and hands away from that router bit. As you can see here, we've got nice clean exit cuts with no tear out. Now our next two cuts will be going in this direction, so the tear out would occur on this inside face, so we need to address that. And that was the purpose of making that one test cut earlier along the edge of one of the pieces of stock. Now before I make the coping cut on this end, what I'll do with that scrap piece of stock, I'll assemble the two pieces together, lining up their ends so that they're flush, and then that cut, or that coping cut that we made on the scrap block, will support the material for the exit cut on our next routing operation. Now keep in mind that you only make these coping cuts on your rails, not the stiles. Now as you can see in this area how the rail meets up with the stile with that nice coped cut. Now at this point we're going to turn our attention to making the field panels. Now we've mentioned before how we establish the distance or thickness of our field panels, and that would be from this back edge of the groove to this face on your stiles and rails. And the way we're currently set up, we should be working with a 5/8 inch thick panel. And if we were working with a 5/8 inch thick panel, we could do our field panel cuts all from one side. But in this particular example, I'm going to show you how to work with 3/4 inch thick stock so that the front face is flush with the front and the back is flush with the back edge of our stiles and rails. So this is the field panel that we'll be working with, as well as another one when we get to our second demonstration. At the router table, there's two basic types of tools that we can use to raise a panel. This particular one is, again, from Whiteside. It's part number 6000C. It's a fairly large diameter router bit, so you do need a good high horsepower router with very low RPM. This isn't a bit that you want to run up at 20,000 RPM by any means. The second option is this particular bit. It's called a vertical panel raising bit because it works in a vertical attitude. Again, Whiteside, part number 5804. This particular router bit and this router bit will give us the same exact profile or edge detail on our raised panel. Now the first one we'll show you is the large cutter. Now the first thing you'll do, of course, before even installing this router bit is make sure that your router's on its slowest speed setting. And then unfortunately, on router tables such as this one, getting the wrenches in there to tighten it can be a bit of a problem. So you'll have to play around a little bit to make sure everything's going to work out fine to tighten it up. Of course, every time you're adjusting or changing router bits on a router, unplug it for safety. Now you'll notice that my insert plate is really just too small in diameter. As I lower this router bit down, you'll see that I won't even be able to get an insert plate in my router table insert. Notice how the diameter of the router bit is exactly the diameter of both the router base and my router table insert. Now Now many people, when they work with these large router bits, they have it in their mind that they have to take the entire cut all at once. That's not really the case at all. With this size router bit, or even any other type of router bit for that matter, you don't have to take the cut all at once. You can lower this router bit and then take a series of progressively deeper cuts coming up on the height of the router bit, or bury the router bit in your fence, moving the fence away, exposing more of the router bit. I myself do it both ways. Frankly, I don't think it matters which approach you take, but just don't take it all in one cut. It's just much safer and much easier to control the workpiece when taking a series of light cuts. Now, as you can see, what we're going to be doing is passing our stock over the router bit, doing our end grain first, then our long grain. That's a very large cutter. It's very dangerous, so I've got it buried as far as I can get it inside my fence, but still making sure that the pilot bearing is riding a little bit proud. I'm going to be using some large push blocks that will give me real good control over moving this workpiece over that router bit. And again, I can't emphasize enough the importance of not trying to do that all in one cut. And this is where we're at after 2 cuts. We're almost to depth. Now keep in mind, I'm working with 3/4 inch thick stock. If I were working with 5/8 inch thick stock, I'd want the thickness here to be 1/4 inch. But because I've got the thicker stock, I want to end up with 3/8 inch of thickness in this area. Now for this last finishing cut, I'm going to be taking about 25 thousandths of an inch, and I'm using my dial indicator to ensure accuracy of this setup. Now if our field panel material was 5/8 inch thick, we'd be done now. However, as you can see, our 3/8 thickness right here, because my field panel is 3/4 inch thick material, won't fit inside of our groove. So what we need to do now is perform the same operation on the back side of the panel. But now we're not going to go, of course, nearly as deep. All we need to do is just remove 1/8 inch of material from this back edge. And we can use the same router bit to perform that operation. Now, of course, you can measure this with the conventional tools. However, again, I like the precision that the dial indicator gives me. And what I'm doing right now is setting my indicator for 0 at the table surface. We know we need 1/8 inch cut. So now what I'll do is I'll move the indicator over on top of one of the flutes. And then I'll lower my cutter down and then bring it back up so that I get exactly a 1/8 inch depth of cut. Okay, right now the cutter is perfectly flush with the table surface and will come up 1/8 inch. That's 125 thousandths. Lock her in, adjust our fence over, and we're ready to cut again. And this is what our completed frame and panel door looks like. Now, of course, that nice large diameter panel raising bit gave us a wonderful finish on that machined surface. This area here hasn't even been sanded, and there's even some tear out in it, so please ignore that. The shadow lines that are created by these vertical transitions between the face of the rail and that roundover add a very nice classical touch. We've also got that sharp radius terminating up near the face. Again, nice dark shadow line, creating a very, very nice classical touch. Now this is very conventional for a raised panel door. In fact, when we requested this particular router bit from Whiteside, I specifically stated I wanted the most commonly used one. So this is probably the most common form of raised panel doors that you'll see. It's a very, very nice classical traditional look. Just another design element for you to notice, of course, we've got this dark area. Again, depending on how you feel about these things. For me, I don't mind that at all in my finished piece. I think it adds a very interesting visual effect to it. Now again, I mentioned that this is 3/4 inch field panel. This isn't glued together, so hopefully it won't fall apart on me. But on the back side of the panel, you can see how that small raised area allows us to use 3/4 inch thick stock for our field panels. And that just adds a little bit more weight to the door and gives it a sturdier feel. Now let's take a look at raising a panel using a vertical panel raising router bit. Now with the vertical panel raising bit, we have a little bit more latitude with regard to how much reveal there is in this low area between the panel and the rail. And that's controlled by how high we adjust the router bit to cut. Now for the purposes of our demonstration, what I actually want is to have them both the same. So I'm going to adjust my router bit height so that it's equal to what we got with our horizontal bit. Now because this is a vertical panel raising bit, we're going to be passing our panel across the router bit vertically. So a tall fence is very beneficial for this operation. Now if you have a shorter fence, you can always attach a taller auxiliary fence to your existing one. In this particular case with this size panel, I should be all right because I'll be feeding the stock through using my gripper as a push block like so. And that completes our first side. Now we need to do the same as we did on the other horizontal bit. We need to raise the panel on the back side as well because this is 3/4 inch thick stock. So an adjustment to the fence, a few more cuts, and we're done with this panel. Well, as you can see, they're both identical panels, obviously machined completely differently. Now, I'll be the first to admit right away that those large diameter router bits, while very intimidating, give an outstanding finish. There's probably just about no sanding required on this particular surface. On the panel where we use the vertical panel raising bit, of course I can see the mill marks along the long grain. The end grain is a little bit fuzzy. It's not as smooth of a surface as we got with the large horizontal bit. But as you can see, the front of the panels are identical, as are the backs of the panels. So the two different router bits will give us identical panels. The choice is yours. If you want less sanding and less secondary work, the large horizontal bit certainly works better. It's much more intimidating, perhaps more dangerous. The vertical panel raising bit, smaller in diameter, so it's less intimidating, but gives you a rougher surface. It's not quite finish ready, so to speak. So make that decision based on that experience right there. Once you look at a 3-inch or 3.5 inch diameter router bit, it's very intimidating, but they do perform very well. So that should give you an idea of a classical, traditional raised panel and how we go about machining the stiles and rails, as well as raising the panel on a router table two different ways, with a horizontal bit and a vertical panel raising bit. Now I'd like to point out that these are all very classic traditional designs. There's nothing wrong with them. They're perfect when making period furniture or even reproduction furniture where the moldings or the details are appropriate. Now, of course, elsewhere in this issue, we're going to be looking at a variety of different raised panels, perhaps more contemporary in styling, but you can work with these same bits that we use to do the stile and rail machining with those other field panels. Just be sure to keep in mind the offset distance from the face of the panel to where the groove lines up. Once you understand that offset, you're in great shape to make your own custom field panels.